Hello students, good morning! In this tutorial, we will be discussing multiplication of polynomials, particularly binomial times a binomial, but using shortcuts since these are special products. Now, here are concepts you need to recall. Remember, you can check these topics from our other tutorials or go to other parts of this lesson by simply checking out the links or timestamps on the description below. From the get-go, let us try to show a critical concept in algebra, something that others might find confusing. Let's compare these two. Okay, let's solve this first. The square of the quantity x plus 3. Let's do this quickly. So we can distribute the exponent 2 to both x and 3. So this is x squared plus 3 squared. Finally, it's x squared plus 3 squared is 9. Done. This time, let's simplify the square of the quantity 3x. So we can distribute the exponent 2 to both 3 and x. So this is 3 squared times x squared. Finally, it's equal to 9x squared. Done. Pero teka, parang may mali. How come these two look totally different, yet we solve them using exactly the same method? Let's look at the second expression again, where we distributed the exponent 2. We did that because we can recall a familiar rule of exponent, which states that the quantity AB raised to m is equal to A raised to m times B raised to m. Take note that we distributed the exponent m like so because the base here is a monomial. And this rule, distributing the exponent, only works if the base has only one term. Applying distribution of the exponent here in the second expression, which has a monomial base, is therefore correct. Now, if we go back to the first expression, the base is a binomial. Therefore, we cannot apply this rule. We should not have distributed the exponent. Which means, yep, we were too in a hurry and we were careless. Aww. Before somebody kills me in the comments, let's cross this out fast. If it's any consolation, it's a common mistake, which we are correcting now. How do we get an equivalent value of this then? Let's solve this by looking at a much simpler problem. What does y squared mean? Note that we can expand this. So it's equal to the base y multiplied by itself, or y times y. Now, applying this same concept to the original expression on top, let's expand the square of the quantity x plus 3. Since the base is a binomial, we multiply this base by itself, meaning it's equal to x plus 3 times the quantity x plus 3. This product of two binomials should be easily solved by using the FOIL method. Let's write F, O, I, L as guide. First terms, x times x is x squared. Then outer terms, x times 3 is 3x. Inner terms, 3 times x is 3x. Last terms, 3 times 3 is 9. Combining these like terms, we have x squared, 3x plus 3x is plus 6x, then plus 9, resulting to this correct answer. And it's a trinomial, not a binomial, like we carelessly answered earlier. Summarizing, if we have a monomial base, distribute the exponent. If we have a binomial base, we expand and then multiply. So, how is this related to this lesson? This is actually an example of a special product. It's called the square of a binomial. Let's look for the shortcut of the squaring of a binomial by solving and looking for patterns in some examples. First up, what is the square of the quantity x plus y? Basing from our previous example, we expand first, like so. Then we multiply by FOIL. Let's quickly show that the first terms, x times x is x squared. Outer terms, x times y is xy. Inner terms, y times x is xy. Last terms, y times y is y squared. As usual, the product of the outer and inner are like terms, so we can combine them. We now have x squared, then 1xy plus 1xy is positive 2xy, and finally y squared. Now let's try a slightly different item. What is the square of x minus y? So, again, we expand first, like so. Then again, we multiply by FOIL. Let's quickly show that the first terms, x times x is x squared. Outer terms, be careful this time. X times negative y is minus or negative xy. Inner terms, negative y times x is minus xy or negative xy. Last terms, negative y times negative y is positive y squared. As usual, the product of the outer and inner are like terms, so we can combine the outer and inner. So we now have x squared, then negative 1xy minus 1xy is negative 2xy, and finally y squared. Now, as we continue, let's investigate at patterns that we can already see here. First, a very obvious one. The square of a binomial is a trinomial. That is true for the first example as well as for the second. In the answers, we have here the leading term, then the middle term, and then the third term. Now, let's figure out the steps to quickly get these three terms in the final answer. Looking at the leading term in the answer here, we can observe since we are squaring binomials, we are multiplying the binomial by an equal binomial. Therefore, when doing the FOIL method, the product of the first terms, since they are equal, is simply the square of the first term here. Again, let us generalize. To get the leading term here, we simply square the first term. That is true for the first example since squaring the first term x is x squared. That is also true for the second example since squaring the first term x is x squared. Next, there's good news. Looking at the third term in the answer here, we observe a similar pattern. Again, as we are squaring binomials, the last terms are equal. A quick way to get the third term in the answer is simply squaring the last term. Again, let us generalize. To get the third term, we simply square the last term. That is true for the first example since squaring the last term, positive y, is positive y squared. That is also true for the second example since squaring the last term, negative y, is also positive y squared. Now, remember that even negative numbers, when squared, produces a positive value. Thus, we can further generalize that since these are perfect squares, they will always be positive. Finally, we go to the middle term of this trinomial here. We know that it's the sum of the product of the outer terms and of the inner terms. And if these binomials are equal, these products, outer and inner, must also be equal. So a quick way to add them, the two equal values, is to simply multiply by 2, meaning to add xy plus xy, simply double xy. We can generalize then, to get the middle term, we simply double the product of the two terms. That is true for the first example since multiplying the two terms, x times y is xy. Double it and it's 2xy. That is also true for the second example since multiplying the two terms, x times negative y is negative xy. Double it and it's negative or minus 2xy. That means, yep, we can skip this long part as a shortcut. It's time to apply these steps to quickly get the square of a binomial. Let's have example number 1, the square of x plus 1. Step 1, square the first term. Therefore, the square of x is x squared. Step 2, double the product of these two terms. Here's a tip. If you want to do this mentally, it's easier if you multiply the two terms first, then double it. Let's do that. Multiply x and 1, it's 1x. Double 1x, it's 2x. Middle term done. And step 3, square the last term. Therefore, the square of 1 is 1 squared or 1. We now have the final answer. Easy? Example number 2. The square of the quantity x minus 4. Step 1. Square the first term. Therefore, the square of x is simply x squared. Step 2. Double the product of these two terms. Let's do that mentally. Multiply x and negative 4. It's negative 4x. Double negative 4x. It's negative or minus 8x. Middle term done. Step 3. Square the last term. Therefore, the square of negative 4 is positive or plus 16. This is the answer. Take note that this is consistent with our observation earlier that the first and last terms of the answer are perfect squares and they are always positive. Getting better? And faster? Okay, last example. Let's make things a little more challenging this time. The square of the quantity 3x plus 2. First step. Square the first term. Therefore, the square of 3x should be solved first. Now, be careful here and let's show our scratch work. Let's write the quantity 3x squared. This looks familiar because we have solved this earlier. The base is a monomial, therefore, by rules of exponents, distribute 2. And therefore, we have 3 squared, then x squared, or 9x squared. That is our first term. Next, double the product of these two terms. Let's do that. Multiply 3x and 2, it's 6x. Double 6x, it's positive or plus 12x. Finally, square the last term. Therefore, the square of 2 is positive or plus 4. This is the answer. By the way, the product of the same binomials or the square of a binomial is called a perfect square trinomial. Don't worry, that's for another tutorial. You are now given a chance to answer some exercises. Don't worry, the answers will be shown in a while. You can try this now and pause the video. Kaya yan, go! Here are the answers so you can check. So how did it go? Here's another set of questions. Again, you can pause this video and do this. Go! Here are the answers so you can check. On to our next special product. This is called the product of the sum and difference of the same two terms. Whew! I know that name is a mouthful. Ang haba ng pangalan. But what do we exactly mean? Here's an example to show that. Let me read that again. The product of the sum and the difference of the same two terms. Get it? Okay. We know, of course, this is a binomial times a binomial which can be multiplied using the FOIL method. Let's try and do that. First terms, x times x is x squared. Outer terms, x times negative y is negative or minus xy. Inner terms, y times x is positive or plus xy. And the last terms, y times negative y is negative or minus y squared. As usual, the product of the outer terms and the product of the inner terms are like terms. They can be combined. So simplifying, we now have x squared negative xy plus xy is 0xy, which means we can simply cancel them. And finally, minus y squared. So this is the answer. Now let's look at another example. Again, we have the product of the sum and the difference of the same two terms. But before we continue, it's important to note that whether the binomials are multiplied like this or like in the original question, they are equal. This is true because of the commutative property of multiplication. So still, this can be considered as the product of the sum and difference of the same two terms. Well, just a reminder. So, we multiply again using FOIL method. Doing that, we have the first terms, m times m is m squared. Outer terms, m times negative 3 is negative or minus 3m. Inner terms, 3 times m is positive or plus 3m. And the last terms, 3 times negative 3 is negative or minus 3 squared or 9. Simplifying the polynomial, we have m squared, negative 3m plus 3m can be cancelled, and finally, minus 9. So this is the answer. It's time to investigate and figure out a shortcut. First observation. The product of the sum and difference of the same two terms is a binomial. We only have a first term and a second term. There is no middle term since the outer and inner products will be cancelled. So, here are the steps to get the answer. Step 1. Square the first term. Since the first terms are equal, the FOIL method should give us a squared first term. Another observation is that the answer is always a difference. That is true for both the first example as well as for the second. Which brings us to step 2. Subtract the square of the last term. Since the last terms are also equal in value but different in signs, the FOIL method should give us a squared last term. Easy, right? Also, take note that in the binomial answer, this is a perfect square, this is also a perfect square, and this is a difference. That's why the answer is called a difference of two squares. A topic for another tutorial. Again, we can skip this FOIL part and let's apply these shortcuts to some examples. Example number 4. Quantity x plus 6 times the quantity x minus 6. Notice this is a product of the sum and difference of the same two terms, so we can use our shortcut and expect a binomial answer here. Warning: these shortcuts can only be used for special cases. Okay, first step, square the first term. So we write x squared. Second step, subtract the square of the last term. This will then be a difference. Then 6 squared is 36. This is the answer. Well, that was quick. Okay, ready for example number 5. Quantity z minus 5 times the quantity z plus 5. Again, we know this is a product of the sum and difference of the same two terms. So we can again use our shortcut and expect another binomial answer. First step, square the first term. So we write z squared. Second step, subtract the square of the last term. This will then be a difference. Then 5 squared is 25. This is the answer. Nice. Last example, quantity 2x plus 7 times the quantity 2x minus 7. This is a product of the sum and difference, thus another binomial answer. First step, square the first term. So we write the quantity 2x squared. Let's do our scratch work here. Remember that the base is a monomial, so let's try to be more cautious here. We should distribute the exponent like so. So we write 2 squared, then x squared. And this is 4x squared, our first term. Second step, subtract the square of the last term. We write minus, then 7 squared is 49. This is the answer. Easy. We are now ready for some exercises. Here are exercises 9 to 16. How quickly can you do these? You can pause this video to do this on your own. Don't worry, the answers will be shown later. You can try this now and pause the video. Go! Here are the answers so you can check. Kumusta? Kaya ba? Here are more drills, exercises 17 to 20. Let's make it more challenging by mixing the two special cases, the square of a binomial and the product of the sum and difference. I hope you can distinguish what belongs to each case. You can go back to the tutorial if you need to. You can pause this video to do this on your own. Go! Here are the answers. Did you get them? Okay, you may need more exercises, so here are numbers 21 to 24. Pause this video now and answer. Go! Here are the answers. Did you get them this time? Let's try some more. Do these exercises from numbers 25 to 32. Again, you may pause this video now. Go! Here are the answers. Kumusta? I hope you got all of them. Please don't forget to like and subscribe. Happy solving!